Alright. What I like to do is at least just go through this problem as being able to solve this equation. So first thing I want to do is remember we have all of our properties that we can use. However, the only time we've used all those properties is whenever we're dealt with, a logarithm or we have an exponent kind of isolated. So the first thing I notice here is I have this subtract 9. Well, I can undo that subtract 9 by adding 9 to the other side. So what I'm going to do is I'm going to first add a 9 to the other side. Then what I have is just e to the x equals 10. And what I'm going to have to remind myself is, remember when I have a variable.
Whoa.
Yeah.
There you go. Thank you. If I look at this, for some reason I was thinking subtract. I don't know, this subtraction. So now what I have is I have my variable as the exponent, right?
Yes.
So I need to some way to get rid of that. So there's a couple ways we can look at this. One way we could do is we could change it. This is in exponential form. We have an exponent here. All right? And what we need to do is we need to get that exponent down. So what we can do is we can either put it in logarithmic form, or another way we can look at this is, if you guys remember this property, ln of e raised to the x equals x. You guys remember that?
Yes.
Right? Anytime you're taking, or it doesn't even matter if it's ln, but log base a of a equals x equals x. Whenever you're taking the base, evaluating a logarithm with the same base, it's going to equal whatever that's raised to that exponent. Because log base a of a equals 1, or ln of e equals 1, right? A raised to what power gives you a? It's 1, right? E raised to what power gives you e? It's 1. So here, one way I can do it, you could transfer to exponential form, but once you guys get in the realization, you can also take the logarithm of both sides. Just like you can take, just like you can add 1 on both sides, you can also take the logarithm of both sides. So I take the logarithm of both sides, and what happens is now that's going to cancel out and just give me x equals ln of 28. Okay? And that's pretty much solving. Like I said, if you calculate, you can go ahead and approximate the solution, and then go ahead and test that answer to make sure it's correct. But for right now, I'm just going to worry about you guys understand the answer. So you can just type in your calculator ln of 28 to find your approximate solution. But pretty much isolate and solve. Yes.
Because base of ln is e.
Correct. That's why I would cancel out.
Awesome.
Yep.